Hey, good morning, troops. Many of you guys are hopefully studying your polyatomic ions for ionic naming. We are going to get into a new naming today. It's called molecular compounds. So with ionic compounds, we were dealing with metal, non-metal, metals, non-metals, okay, which means we had a plus and a minus, which means they were coming left of the periodic table, right of the periodic table. Well, today we're going to be dealing with molecular compounds. Sometimes they are called covalent compounds. Now, last week we talked about covalent bonds, very strong bonds when they're intramolecularly bonded or within each other. Okay, so molecular compounds are the combination of two nonmetals. Okay, two nonmetals. And when you go to put them together, they're going to take on a different naming trend. But if you guys look in your book on page 248, we're also going to be able to write a few things down. So if you would, have some paper out and we will write some things down. So in your book on page 248, you see a list of prefixes that are going to be used for you. Now, these prefixes are going to help you name the number of atoms that you have of that particular compound. Okay, so on your notes, here are a couple things that you need to write down. So the rules, they are going to be similar to ionic naming. Which, if you think about it, the IDE ending coming off of the periodic table, okay, so all elements that come off the periodic table, okay, on the negative or the anion side are going to end in an IDE ending, okay. So if you guys look on your book, page 248, okay, you guys see all of the prefixes that are going to be used here. So for instance, if something has one atom in it, you would say mono. If it's something would to have two in it, you would say di. Something would have three, tri, and so on and so forth. So if you get a compound that says SiO2. Now, the first thing you need to do when looking at something like this is say, okay, well, how is this going to differ from ionic bonding? Well, let's look at the first element. Is the first element to the right of the periodic table? Yes, it is. It is not a metal. So right there, you're dealing with two nonmetals. So the first one, you need to ask yourself, is it going to be a metal or is it going to be a nonmetal? So since it is a nonmetal, we know it's a molecular compound, and we can come to our book and say, what are the prefixes involved here? Okay? Now, since this is one element or one atom, you would say, oh, I think I might say monosilicon. Okay? But as you can read in your book, there are exceptions to using the prefixes shown down here. Mono is never ever used on the first atom or the first element in your naming. So never use mono on the first element. And if you look in your book, never use mono on the first element. If you look in your book, that is all right here. Okay, that is all right here. So what we're going to do is just simply name this silicon. Okay, now O2. So how many atoms of oxygen do we have here? Yes, we have 2. So if you look back at your chart, 2 is di. So we would say di, And what is the name of this element according to our rules, similar to ionic naming, gets the IDE ending. So we would say silicon dioxide. Silicon dioxide. Okay, let's look at another one. PCl3. So again, we have one atom here. We aren't going to use the term mono on it, so we would just name it phosphorus. Now, how many atoms of our second element do we have? We have 3. So we would come over here and say, okay, here's 3. It's tri. Okay, so we're going to use tri. And what is the name of that element? Phosphorus trichloride. Okay, let's do another one. N2O. Okay, now this is the first time we have not seen mono being used on the first element. Okay, so how many atoms do we have here? 2. So we go over here and we see di. So we are going to use our prefix in this case and say di-nitrogen. Okay. Now this is also the first time where we have seen one element in the second term. So now we have to use mono. The mono was also never used on the first element only. You can use it on the second element. So since we have only one oxygen, we would call it monoxide. Okay, now I'm asking you this question because this term monoxide should sound familiar to you guys. Where have we heard monoxide before? Yeah, that's right. Carbon monoxide. So let's think about the formula for this. Carbon monoxide. So we know that carbon is never used with mono. So we would write it like that. Monoxide we just did here, so whatever's here has to be there. So we would write this as CO. So the name of that is carbon monoxide. This is the deadly gas as a result of bad ventilation in your heating elements at home. And this is a gas that can leak into your house. You can't smell it. You can die from it. Gives you bad headaches to start out with. But carbon monoxide is a byproduct of combustion. So if it's not vented properly, hopefully you guys have some carbon monoxide detectors in your home that would help you be alerted to this deadly gas. But that is the naming of carbon monoxide. Let's do a few more. N2O5. So how many nitrogens do we have here? 2. Dinitrogen. Pent, because 5 is penta. Okay. 5 is penta. There it is. Come on, Auto. There we go. 5 is penta. So we are going to say pentoxide. Okay. Now you notice I cut off the A there. A lot of people will say pentaoxide or pentoxide. So whatever feels comfortable to you, we will name it in that way. Okay. Let's do another one. SF6. Again, we don't say mono, so we're just going to say sulfur. We are going to say 6. So what is 6? Hexa. So we're going to say hexafluoride. Okay? So now that you know how to name molecular compounds or covalent compounds, The prefixes should be easy. They should be fairly recognizable. The only ones that might not sound like they go would be the tetra. That is our first one, but that should be good. So mono, di, tetra, penta, hexa, hepta, octa, nona, and deca. Those are our prefixes. You can refer to your book during this time, and I will give you a set of problems now so that you can do some problems. So good luck with this. We will use hydrates and acids tomorrow, so please work on this, and I will also ask you to do some reading with this for tomorrow. Hope everything's working well. Make sure you study your ionic compounds, polyatomic ions, and that you should be good to go. So hopefully you have a good day. We'll see you when we get back. Talk to you later.